Good morning, everybody. We have seen the formulation for horizontal separator and vertical separator. Okay, and we have done some calculation for vertical separator also. Today, I'll try to do some calculation on horizontal separator, and I'll try to formulate something which is not following the specific rule whatever I followed till time. Like if separator is filled by lower amount of liquid or maybe higher amount of liquid, then the 50% gas fill or 50% liquid fill formula will not hold. So in that case, we have to change the formula. So how to change the formula we'll discuss in this lecture. Okay. So numerical for problems basically on horizontal separator, because vertical separator discussion already done. Okay, and it will be 50% gas filled, or you can say 50% liquid filled, because okay. So if I have any separator, 50% will be liquid, 50% will be gas. Okay, and when 50% liquid, it will have again two layers. One will be oil, one will be water. Okay, so this way we'll try to calculate some given data will be there, and based on that you have to calculate separator size, seam to seam length, and slenderness ratio. Okay, 50% liquid. Here liquid means oil plus gas, oil plus water. Okay, 50% gas we are considering. Okay, let's see the problem. A three-phase gravity separator, horizontal, we are assuming. Okay, we are assuming a horizontal separator, and it is three phase. Three phase means I will have oil layer, and I will have water layer also, and gas. And gas will be going out, and oil I have to take here, and water. Okay, and inlet will be here. Just I am not drawing any other specific equipment, for example wave breaker or anything. So just is we are assuming there is nothing. It is a simple separator, and we have to calculate what will be the approximate size for diameter, approximate length, seam to seam length, and effective length of separation. Okay, and we are assuming oil flow rate 5000 barrel per day. Again this unit you can write BPD, BOPD, or B per D, or barrel per day in full form. So anyway, capital letter, small letter you can write. Okay, water flow rate 3000 barrel per day, or BWPD also you can write. Okay, so many books will be using different type of symbols. Gas flow rate MMSCFD, D should be there. 5 million standard cubic feet per day. Per day means you are writing D term. Operating pressure 100 psi, absolute pressure. Operating temperature 90 degree Fahrenheit, oil gravity 30 degree API, specific gravity 0.6, and we are assuming is related to air. Specific gravity water, fresh water if we assume 1, then little bit higher gravity is there, whatever water you are using. Retention time 10 minutes, and retention time 10 minutes for both oil and water. Viscosity we are assuming with oil viscosity, we are assuming 10 cp, and we are assuming some more data like drag coefficient 0.851. So normally it will be done calculated using iterative process, but presently just for simplification I am giving one value, drag coefficient. If we ask you to calculate drag coefficient, then actually you have to start CD value, that coefficient of drag. So that value 0.34 you are assuming, you are calculating Reynolds number, again you are calculating back to drag coefficient. So that iterative loop will be very much longer. So I am not going through that route, rather I am giving just drag coefficient so that you can do step by step calculation. So I will assume in exam also you do step by step calculation and solve the problem. Water droplet size 500 micron. So we are assuming little bit bigger water droplet, but oil droplet falling. Okay, when inlet fluid is there, oil water droplet will be there. So water droplet, if it is higher, it will be falling quicker, but water droplet will be quicker falling, but oil droplet will be a little bit slower. So based on this oil droplet calculation, we will do the initial gas capacity based calculation. But when we are calculating for oil and water layers, so in that case we will assume that water particles are there in oil, and it's falling down, and in that case we will be assuming droplet size 500 micron, little bit bigger water particle size or droplet size. Okay, many time I say particle, many time I say droplet, so both are same actually. Oil droplet, okay. Compressibility factor of gas 0.84 we are taking, and one more thing we are assuming, one value beta will be there. So later I will discuss beta. HO max, HO max by beta equals D max. This formula will be using actually. Okay, and beta value will be getting from some chart. So later we'll see. Okay. Now try to solve the problem. So first we have to calculate gravity. Okay, API gravity is given. So you have to calculate del Sg. Okay, in formula we will use this del Sg, or specific gravity difference between oil and water. So del Sg means del Sg oil, specific gravity of oil, no, specific gravity of water, Sg oil, water will be little bit higher. Okay, so the formula will be like this. Sg water already given 1.07, where Sg oil you have to calculate. Okay, so Sg oil, how to get it? So Sg oil you get from 14.141.5 divided by Sg oil, oh sorry, this mistake, API gravity equals 141.5 divided by Sg oil minus 131.5. So this value will be coming as, if I manipulate this one like this, Sg oil equals 131.5 plus okay, mistake, Sg oil equals 141.5 divided by 30 plus 131.5, because 30 means 30 degree API already given here. Okay, if you see left side. Okay, so this value will be coming as a 0 del, sorry, SGO 0.876. Okay, now del Sg is coming, Sg water 1.07, this is coming here, 1.07 minus 0.876, so it is coming as 0.194. okay, Sg del Sg difference. Now we'll go to gas capacity based calculation. Gas capacity based calculation. Okay, so in previous chapter or previous lectures we have seen this formula is that like this: D effective length equals 420, I said that IPC 420, so you can remember TZQ by P rho G by rho 0 minus rho O minus rho G, CD by dm dm. Okay, now if I want to put the data, 420 constant, T means 460 divided by 90 plus 90, and Z value I have already given 0.84, and Q value you have to calculate actually. So Q I will keep it blank now, and P value already given 100 psia, I am putting as it is. So I am not putting Q value now. First I will calculate after that put. Okay. Now rho G and this part I have to calculate. Okay. And CD value given 0.851, and dm is given, dm value given 100. Okay, power half. So here C I did not put here two three values. So Q equals, okay, so Yeah, Q is given 5 mmSCF, so I'll be putting 5, and rho G and rho L. So rho G formula is like this: G rho G equals 2.70 SP divided by TZ. Formula we have seen before. So 2.7 into SP is S is given 0.6, that specific gravity of gas. P is pressure 100 psi given. T Rankine temperature 460 plus 90 into Z 0.84. Okay, so this will be giving 0.35, and rho liquid again 2 points. This is 62.4, 141.5, 131.5 plus API. Okay, so this is giving 56.6 pound per FTQ. Okay, now CD value is given, so I'll be calculating DLEFF. So here you can remember D inch and LEFF in feet. Okay, 420, and again I'm putting digits here, it is coming. T means 4550 into 0.84 into 5 divided by 100, and rho G value I am getting 0.35 divided by, what is the value, 56.5, 56.6 minus 0.35 into 0.851 by 100 per half. Okay, so this value is calculated as 102. Okay, from this 102, actually you have to calculate, make one table, D and L effective length. Okay, so D in inch and effective length in feet. Okay, so if we change D and L D value, then effective length will also be varying. Okay, from this calculation. So they have assumed, like initially you assume 60, 72, 84, 96. Then effective length also coming like 1.7, 1.4, 1.2. They are calculating like this. Okay, 1. Use a low value of effective length. Okay, so low effective length like 1.1. Okay, so we have to use a larger value of effective length. Lower value if we are using, then actually gas capacity equation will not hold. So in that case we can ignore that. Okay, now we have to calculate maximum oil pad thickness. Max oil pad. Okay, maximum oil pad thickness. Okay, this one HO, this is HW. Okay, so maximum oil pad thickness you have to calculate. So HO max, you have seen the previous lecture. If you see the formula, I'm not deriving again, because in previous lecture we have derived 0.00128 TRO del SG dm square divided by mu. Okay, so this value, if I put all the data, so it will be like 0.00128, TR is 10, del SG I have already obtained 0.194, and DM 500 square, and divided by viscosity 10 viscosity of oil. Okay, so finally this value will be coming 62.1. Okay, now if we calculate D max from here, so we have to go to the table, chart. Okay, in previous lecture I have shown one chart actually like this. Okay, you can remember 0.5 to 0 and 0 to 0.5, and this is a water level area divided by total area, and this is beta equals HO divided by D, diameter. So this curve was coming like this. Okay. So previous lecture I have shown this graph. Now in exam I can give the graph to find beta value, or I can give the value of beta and you can calculate. So in the present case I am giving you the value beta like 0.257. Beta equals 0.257. Okay. So if you have 0.257, then in that case we can calculate D max equals HO max, already we have obtained, and beta value 0.257. So these two if we calculate, so D max is coming as 24.16 inch. Now liquid retention time you have to calculate. Liquid retention time. Okay, if we calculate liquid retention time, previous formula you remember, L effective length equals 1.42 into Q water TR water plus Q oil TR oil. Okay. So this value if I put 1.42 Q water is 10, Q water is 3000 into 10 plus Q oil is 5000 already given in the problem into 10. So altogether coming 113,600. Okay, D square LEFF. Now complete combination of D LEFF, D effective length, LSS, 12 LSS by D. Okay, this table you have to prepare, and you have to check unit also. This is inch, this is feet, this is also feet, this is ratio. So slenderness ratio is not, it should not have any unit, and you take the values like 60, 72, 84, 96, 108, and you get 31.6, 21.9, then you get 16.1, 12.3, 9.7, and LSS you can calculate using the formula LEFF. So LSS equals LEFF divided by 0.75, or LSS equals L effective length divided by D by 12. Okay, so take the bigger one and use it. So LSS you got 42.1, 29.2, 21.5, 16.4, 13.0, and again slenderness ratio we are getting 8.4, it's too high. 4.9 is coming down, 3.1 it will be reasonable, 2.1, 1.4. So this value you can calculate from this table. Okay, so after that you can select anything between 3 to 5. Okay, so 3 to 5, so within this range anyone you can select, and you can say okay, this is my slenderness ratio, and respective D value this one, L effective this one, LSS is this one. Okay, this way you are calculating for horizontal separator. Okay, so in exam actually I will be giving similar problem, and because this is too big problem I cannot give for 2 marks or 5 marks, so I will break the problem like this, calculate maybe gas velocity, liquid velocity, calculate effective length and diameter, D square LEFF value, or I'll ask you to calculate beta value, or from beta value I'll give, then I'll ask you to calculate D max. Okay, so some data I'll be giving, some data I'll be missing. So if you understand the whole problem, how to solve step by step, then you can solve, you can give answer actually. But if you try to memorize, then it will be very difficult. So when you are completing the course or this chapter, so what will you do? You just solve problem and vertical separator, horizontal separator, solve the and check how the numerical formulation was done, like different formula I have developed and I have used. So instead of remembering the whole formula, you can try to develop the formula, then you can put the data so that you can remember steps. And in exam I'll give steps based calculation or data or formula, or maybe I'll ask what is the expression for d square LEFF or the value of d square LEFF. Okay, then I'll give some data, initial data. So initial data you have to calculate maybe API, you have to calculate maybe flow rate, you have to calculate age. So one data will be missing and some data will be given. So based on that you have to calculate and you can get these values. Thank you very much. And I'll be talking about next topic. Yeah. Okay, good morning. So we have seen separator calculation for 50% field. Okay, so every time we have assumed in previous lectures, like separator will be 50% field, 50% gas, 50% liquid. Okay, inlet is there, outlet is here, and what outlet is here? Liquid, gas, inlet. Okay, now if some case if my liquid is more than 50%, like say 60% or 70%, or maybe gas 60%, 70%, then what will be the formula, how to calculate? So let's see that one. So let's assume this one capital D. Okay, this one maybe H gas, this one H oil, or H liquid. Let's say assume it's two phase. So just make life simpler. Let's assume life is this one is two phase and this is like say D by 2, the center axis, and this is lower than that. Okay, HL or liquid. Now how to calculate the gas velocity, liquid velocity, liquid retention time? Okay, this velocity of gas. Okay, so V gas or VG will be Q by AG, area of gas, area of gas means this cross sectional area, this portion. Okay, this area. Okay, this is gas area, gas, that amount of gas is being flowing. So it will be like D total minus small h fraction of this one, so capital D again, okay, into total area. Total area means pi by 4 d square. Okay, so this fraction of volume is available for gas. So this will be coming like this, D minus H into D pi by 4. Okay, now gas flow rate feet per second. Let's say if it is given MMSCF, then feet per second, how it will calculate? Q gas, this is MMSCF D. So Q gas into 10 power 6 SCF, same formula you use for MSCF into day per 24 into hour by 3600 into 14.7 divided by pressure into TZ by 520. Okay, so this will be giving 0.327 TZP ZPQG. Okay, so same way you can now you got Q value, so Vg equals 0.327 into TZQ by P divided by pi by 4 into D minus H. So this value got. So here I can say, so D, just forget about previous notations. Here I am using D notation. Let's say D is in inch, the D is in feet, because you are calculating in feet. Okay, so let's say D in feet. okay, h also in feet, okay, instead of inch, instead of creating confusion. Okay, so it will be coming like 0.327 pi by 4 t z q p d d minus h, okay, 2. Now residence time of the gas Tg has to be equal to the time required for the droplet to fall to the gas liquid interface, to Tr. Okay, so Tg effective length divided by Vg. Okay, effective length, L effective length, and Vg we have already seen here. Okay, so Vg value we can write here 4 into 327. Okay, 4 into 0.327 by pi Tz q Pd d minus h. Okay, now Td, I'll be putting next slide. Td Td equals d minus h 0.0119 rho g by rho L minus rho g into Cd by dm half. Okay, so we got the Td value, and okay, so this is coming from Vt formula we are using 0.0119 rho g by rho L minus rho g Cd by dm or half. Okay, we are using this formula. Now Td and now Tg equals Td. So residence time of gas and falling time of liquid, it will be same, we are assuming, for ideal condition. So now this equation will give like this: L effective length P d d minus h T z q d minus h rho g by rho L minus rho g C d by dm or half into 0.0119 into 4 into 0.327 divided by pi. Okay, or d effective length is coming like Tz q rho g rho L minus rho g Cd dm or half into 0.0119 into 4 into 0.327 divided by pi. Okay, so you can see the formula basically same, Tz q by p. Okay, basically same, only the constant term is getting changed. Okay, so finally this will be giving like 4.995 into 10 power minus 3 Tzq by p rho g by rho L minus rho g Cd by dm power half. Okay, so this way you can derive the formula for D effective length. Similarly, you can calculate for liquid capacity. Okay, now for liquid capacity, so liquid capacity retention time Tr equals volume by Q. So volume is equal to H by first draw the picture. Okay, this one H we have assumed, this is D. Okay, so H by D, the fraction pi d square by 4, this volume is there, so this is giving pi h d by 4. Okay, so equation number will be So you can put equation number 7. This is 7, this is 8. Okay, now Q, you can see Q equals QL into 5.615 cubic feet by barrel. Okay, day by 24 into HR hour by 3600. So this will be giving 0.00065 QL equals 6.5 into 10 power minus 5 QL. Okay, now TR equals pi by 4 HD effective length divided by 6.5 into 10 power minus 5 QL. Okay, now HD HD effective length equals 6.5 into 10 power minus 5 by pi by 4 QL TR. Okay, TR liquid. So this is my formula, HDL effective equals 8.276 into 10 power minus 5 QL TR. Okay, so this one approximately we have derived this one, and if I give any problems using this formula, actually you can try to calculate defective length and diameter. Okay, so thank you very much for this lecture. So next lecture we will start a new topic on oil separator, emulsion separator, that will be containing like heater treater, it will be containing gun barrel, it will containing different emulsion separation techniques also. Thank you very much.